This
We have
conference will now be recorded.
good evening. This is the Telco project monthly call. We have 3 items on the agenda for today. The first one really is just talking about the upcoming OCP summit. Wanted to give the people on the line a summary of what we've seen so far in terms of submissions. We have been allocated a full afternoon for Edge track as part of the Telco project. And so far we have 10 submissions. They all look pretty good from my point of view at this point. I haven't reviewed them completely. But we will be talking about topics related to both edge platforms, edge compute, and also we have a couple of papers related to the core router updates, the DCC, and then we have one presentation by the Evenstar group from mostly hosted by Meta in terms of actually an open radio unit that's been presented to OCP and is being accepted and put on the docket for a contribution. So that's kind of the background. We've got looks like a full slate. We'll make some decisions in the next week or so about whether all those presentations will be accepted for the OCP Summit in October. And I think, Ripon, you had one other thing you wanted to add potentially for
I think you covered it well, and I think as you said, a lot of it was we were just trying to figure out how to bring it all together, right? Like you said, there are sessions on edge platforms, some from edge, enterprise edge applications, some from the ORU and stuff, and we were just thinking of if there is a creative way to bring all the folks together on a panel, some of the key folks together on a panel, and so that we can tie some of the common pieces into the theme, which is, where we have been, where we are going, what are the use cases we are seeing, so that, we don't repeat that conversation across each of those presenters. So again, it's still, being discussed, Lauren.
Okay, sounds good. So we'll have a bunch of individual presentations from the folks that have submitted papers, and we may come up with a panel to try and tie it all together. Any questions about that? Hopefully you guys are planning on attending the summit in San Jose here. Second topic for today was a presentation about the next gen 400 gig eMux from AT&T and partners. I am in a position to share the slide set if you want me to do that from my end, or that's probably
Lauren, if I'm able to share it here, if it works, I will do. Otherwise, I will ask you to share it. I think Bob told that you already have the latest deck from me, right?
I do.
Okay.
I'm sorry, is that Shiva?
Yeah, Shiv Kumar from AT&T. Yeah.
Okay, here let's see. Well, we can try to let you present.
Okay. So is that my presentation is the first? Should I start sharing?
Yeah, please start sharing. It's your
Okay.
Oh.
Right,
that works. Excellent.
We can see it.
Oh, good. At least we are working,
Good.
Is it a go for me? Shall I start?
Yep. You're good to go.
All right.
Please proceed.
Yeah. So today I'm going to present next gen 400 gig eMux platform, what we designed for AT&T usage. So it is a joint collaboration effort. But before I start, let me tell you this PowerPoint templates, etc. we used last year. I didn't get the new year this year's template. So If at all you have a new template for 2023, please send me. We'll just port it to the next that particular template. But currently today, I'm going to use the old template itself. All right. So it's a joint collaboration from AT&T, OCP Space, who is our ODM manufacturer in this case, and also I have partners in crime, Intel people, two people, Felipe, Akshay are on the call. So I will be presenting most of the slide, but a few slides here and there, I may just try to offload to somebody. You can speak, maybe Doug and Akshay. I will hand over the ball to you. UFI folks, Kai could not come. No one from UFI are on the call today, but I will cover that portion also. And stop me in between. I may be going like fast or slow. I don't know. Like how much time I have. I didn't know, just to plan my pace. Is 20 minutes or more?
Yeah, that should work out. I think after you, probably Lauren has another session, but I think this is a good one. So, like you said, 20, 25 minutes would work.
Okay.
Good.
So, what is driving the next gen emacs? As very clearly pointed out here. So, always as a service provider, we continue to label to the next leading technology, etc. And basically, all the networking field, connectivity here, like a PON, OLT, etc. They are also undergoing a lot of activity and technology refreshes, and then always bandwidth hungry technologies. Every day it makes us to go to the next level. So currently we have 100 uplinks deployed in our network, and that is always, as I said, the power hungry things makes us to go to 400 gig, etc. I'm not reading each and every bullet as it is, but in general I'm saying. So the data rates and basically that is a whole driver for all these things. At the same time, when you do the disaggregation model, basically we keep the low cost, and also in the industry, merchant silicon, etc., will be undergoing a lot of transformation. They give more flexibility. They're feature-rich. Silicons from Broadcom or any other vendors, we want to always tap that potential to make it low cost, feature-rich in the industry, and try to cater to the higher speed needs of the network. So next gen emacs is one of those. It is a transformation from 100 gig to 400 gig platforms. Any questions? If not, next. So in our AT&T network, our sub networks, we call it by different sub names like mobile connectivity, OLT, NTE networks, etc. They all join, and then we need to provide the Ethernet emacs capability to all those things to connect to our core backbone. That is one of the needs. And of course, as I said about that, we need to do a more efficient data processing at the edge location. So it is kind of like aggregator from different low speed networks. So as I said before, 100 gig to 400 gig, we are trying to go to meet our traffic demand, etc. When we are doing that, the number of interfaces connected to the edge network also gets reduced because we are aggregating and then connecting to the core network. At the same time, always a big service provider like AT&T, we also need to perhaps always connect to our legacy network, which are unfortunately low speed networks. So that also sometimes we need to cater to. So low speed networks also connectivity is established here. This is as per your template. So these are the 5 tenets of compliances. We are open. So openness is there from disaggregation point of view. Our hardware, whatever we have generated, developed with the help of OCP and Broadcom, Intel, etc., is so open. Any NOS provider can really develop a software on top of this, and it's available once you submit to the OCP for other people to even manufacture also. So everything is open. Even the hardware specification will be open, and the NOS can be developed on top of this, and the efficiency as usual. We are trying to be more efficient, not only to make these white boxes. This is not the first white box we have done, right? So in continuation with our earlier commitment, we have been continuously doing the white box designs. This is like a 400 DMAX is one of them. And as usual, we have like a multi-updater built into this particular white box, which has the capability single-handedly to do the upgrade of all the firmware like BIOS, BMC, CPLT, even including right now we are going to include SSD firmware also from various manufacturers, and it has CI and KGI for the main and the backup. Both will be up to date once we use this multi-updater. So multi-updater functionality with one single command, we are able to do all the upgrade activity, and that's what has been implemented. And also, we have worked with the ODM to really make this diagnostic tool on this such that whenever there is a troubleshooting we need to do to isolate hardware problems with the software, with the NOS, directly we can go to the diagnostic mode and see, for example, SFP problem. If there is anything, we can see the eye patterns, etc. So that is not going to involve NOS directly. Hardware with the SFP, etc., will be able to see the eye patterns and then see whether there is any problem with SFP or with the NOS. These are all the helping tools in production. It always works out for us individually. So this is the industry standard. We already given this particular specification published already in the last year DDC version 2. So we continue to follow the same methodology here too. In between, I'm just pausing so that if there is any questions, people can interrupt me. So scale and the sustainability, etc., is going to really help us in the long run. So because we are using the latest and greatest technology from Intel, people are going to tell about their VROC technology. Is one example. We are using VROC technology. So because of that VROC technology, we'll be able to reduce the power requirements, and also the amount of basically when we do this power requirement and also other components reduction on the hardware, it is going to help make that product very sleek. We'll be covering that in later upcoming slides. I'm not going to cover that right now, but I will come to that later.
Hi, Shiva. So
Yep.
in sustainability, you mentioned earlier that some of the focus was to continue to be able to use legacy gear that's to continue to have that lower speed. I think that continuing to use existing hardware rather than replacing it could also potentially be a sustainability item for this solution as well, because it doesn't require you to replace all of your existing equipment in order to upgrade on this path. You're just adding additional. Just a thought I had.
Yeah, you're right in a
Yeah.
way, but it depends on the application also, meaning how many interfaces you need. We'll go to the details in the next slide, how many interfaces of the low speed we are supporting. If it really meets, it's a good point. I'm just agreeing with you, but
Yeah.
it cannot completely replace the legacy equipment, right?
Yeah. No, we don't want to replace all that
Yeah.
old hardware. Some of it we're stuck with due to regulatory issues, etc.
Oh
So
yeah. No.
your point is a good one. Yeah.
Yeah. No worries why it occurs, but you're not just, taking old equipment and discarding it
Correct.
to put in new equipment. You're maintaining. So that is a sustainable,
Correct.
that meets the concept of sustainability. Yeah.
And some
Thank
of
you.
it we don't want to maintain, but we're forced to by regulatory issues. So we have to keep
Yes.
it, and we had to incur it here. So other local carriers will probably have to do the same. So
Yes.
that's part of why
Yes.
we did this. Yep. Thank you.
Good point. Well taken. So you want us to write something here, change a little bit on towards that?
It would
We
be
can do that.
nice. Oh yes, it would be
Okay.
nice to have, the
Fine.
more we're, the OCP is sustainability is something that's new for us, and so the more angles, the more ways that we're being sustainable, the better it is, and it helps other people then to also be able to address the sustainability tenet. So thank you very much.
Sure. We will add. Any more questions? Okay. So here I'm going to go explain about the emacs broad specification. So this 400 gig emacs supports 100 gigs in the southbound, then 400 gigs in the northbound. So these are the things you can see here. That 40 comes from here, and in between there is a 400 gig interfaces, and also 410 gig. Here is the old lower speed I'm talking about. 10 gig or 10 or 25 gig you can configure with SOP28 natively you can do, and also there is 1 gig legacy port you can support. So basically this is the characteristic of this particular box. And the numbering system, as usual, we are always going from 0 onwards. That's how all the white boxes, even the old boxes, are all configured. And we have, as I described before earlier, touch base. Intel Ice Lake is used with the Telco and 1.8 gigahertz with Intel VROC capability, but we'll come to that, what it means, etc., how it is going to help in the new design. This is the first time we're introducing the VROC technology on the white box, so we will come to that. The chip used in this box is Qumran 2C+, and of course, I did not list the capabilities of this Qumran 2C, but if you can add a little bit more onto it, we can add. So I'm open for suggestions, but I did not cover. Meaning, what is the bandwidth of the chip and the core frequency? It doesn't support any fabric interfaces, etc. But so if you want me to say a little bit more on that, I can add it here. But that is, I think, is out of scope, I thought. Do you want us to really talk about Qumran 2C+? What do you think? Is it going to be helpful? Then I can add a little bit here on the Q2C+ features.
Yeah, I think that you're at a high enough level detail at this. Obviously the specification would, the document would have more detail, but this is great for this level, or at least it is for me.
Thank you. Thank you. So I'll cover it.
Might be good to just add the total capacity on it. Like, what's the total capacity? I see the math can be done up here, but
yeah, we should add that, Shiva. Yeah, let's add that.
Yes. Thank you, Doug. Doug, also you can take some notes, but I'm just taking notes too. Yeah.
Yeah, I'm jotting it down.
Yes, thank you. that's a good input. And we are providing timing using the sync key, etc., using our own OCP developed hardware. And we support currently, even though there is no limitation on the MAC addresses, but what from a service provider and a generic consumption perspective, we thought 256 MAC addresses sufficient, so we asked them to make it for 256 addresses. But again, that is definable, and then if anybody wants to change it, it is changeable. But currently, the design is catering to 256 MAC addresses default. Any question on the specification? Oh, by the way, for folks, this unit is already manufactured. We have the alpha unit available to us in our lab, and it will become like a beta, and then it will become GA by the end of this year. It's even available for the public consumption also. So I will hand this slide. I think Intel folks, can you just cover the virtual like a VRAP function?
Thank you, Shiva Kumar. Can you guys hear me okay?
Yes. We can hear you. Yeah.
Perfect. Yeah. Perfect. This is Felipe Pastor from Intel, and I would like to start by thanking Shiva Kumar for inviting my company to explain our contribution to this project. This falls in the storage category, so it's slightly different from the rest of the presentation that is very networking centric. Our main contribution, and the most disruptive one in this generation, has been around fulfilling the requirement to have full redundancy on the storage side of this white box without having a significant implication in terms of cost or complexity. If you guys look at the bottom left, it basically explains what this is all about. In storage redundant systems, traditionally you have either a PCI Express add-in card or a device that sits down on the motherboard that is going to connect over PCI Express to the CPU complex, and it will provide a connectivity to the drives, implementing the RAID 1 or RAID 5, RAID 6 functionality. What Intel has contributed in this design is basically enabling some of the components that we have a hardware level, codename VMD. We have a software code that runs in BIOS, and then drivers that instantiate those virtual drives into the OS in a way that without having additional hardware in the system, we are able to provide RAID 1, RAID 5, and RAID 6 full functionality. That is very disruptive because basically it requires less hardware. On the bottom right, you have a table that kind of compares the different solutions. The first column, hardware RAID, kind of represents the merit of the solution depicted on the far left. VROC, it's basically the design that AT&T embraced, and it could be compared with a software-only Linux driver RAID implementation, which we have on the right-hand side. And basically, we looked at a number of KPIs to explain to the audience why this is a very relevant technology that helps to increase in reliability without bringing any trade-offs in terms of any degradation. So as I explained, there's less hardware required. The RAID workload will be implemented by the main CPU, and all the I/O will be provided by ports that already exist on the CPU. From a reliability perspective, it's the best of the three possible options. When you see on the left-hand side, you see the RAID controller, that becomes a single point of failure. For us, on on our solution, we do not have a single point of failure anymore. And Linux software RAID still requires the main boot drive to be active for the platform to boot, because the RAID controller, software RAID controller, will only come into place once you have booted the platform. So the only way of making sure that you don't have a single point of failure anywhere from a hardware or software perspective is actually with Intel VROC technology. Easy upgradability. Shiva Kumar was making a significant emphasis on the cost of and the processes to enable firmware. In upgrading Intel VROC from a software perspective, it's part of your system BIOS, so it becomes a fairly straightforward, fairly standard way of upgrading. We have error handling isolation, because any drive I/O error will be solved by the technology without exposing that to the OS, which is from a resiliency perspective is a very important piece of the capability. We support, as discussed before, the boot drive is actually incorporated and covered by the technology. Basically, out of 2 drives, any one of them failing, you're still going to be able to boot your platform, something that Linux RAID would not offer you. It's less power because we have less components there in the platform. And then from a supply chain perspective, we all have been paying attention to the marketplace over the last number of years through COVID. Less component complexity definitely brings significant value from an easy to manufacture. And then on the top of the slide, we basically added the key performance indicators for the solution. So we basically claim, based on benchmarks that we can share at your request, that we can increase the IOPS compared with an external solution, while we reduce the overall latency. And then the power efficiency is an obvious one, and we can do all of this while lowering the overall cost of the platform. So we believe that this is a very strong solution, has been proven in the marketplace for years. Intel, this is not a well-known data point, but Intel has been in the RAID market for many, many years. We are battlefield tested, and now we are bringing capabilities that were already in the client and the server space. We are bringing this to the embedded and the telco space, and we think that it will create value that can benefit OCP members that embrace this design. So with that, I'm open for questions, hey guys.
So
is there a specific system firmware that it requires?
Yes, the firmware goes in the BIOS itself. So we basically provide to any ODM that wants to incorporate VROC in their solution, we can provide the module that sits on UEFI BIOS and implements the solution. I should clarify that this is because we are adding significant value. Intel is expecting to be compensated for this, but we didn't get into the licensing model because in a 2-minute description, we thought that it was really out of scope for what we should be communicating. Did I answer your question?
Yes, thank you.
Also,
it's going to be offered in processors. Is this
Yeah.
Skylake, Ice Lake?
This is we are doing this in conjunction with AT&T and UFI for Ice Lake, but we support earlier CPUs, and we will continue to support this moving forward. So we also support this for Sapphire Rapids, and we will support beyond this.
Okay.
Not for the past ones, right? The future.
So this
future,
actually introduces basically integrated RAID technology in SoCs.
Yes, you can put it that way. Yes.
And right now you talk about basically the Xeon, I guess it's like Xeon D class SoCs. Will you migrate any of this functionality down to the Atom line?
Actually, do you know the answer to that question?
Yeah, can you guys hear me?
Yes.
Yes.
All right. So there is currently no plan to migrate it down to Intel Atom or any other CPUs. Currently, it is only available with Xeon E, Xeon D, Xeon W, and Xeon Scalable processors.
Okay.
So we are mainly focusing on the server side of the market.
Yeah. Yeah, so it's a forward-looking question, right? It's like, we get with networking products in particular, we use Xeons, but we also use lower cost embedded things for much of the kind of transport telco marketplace. And I can see where, if this requirement is coming into products that are, active in, AT&T's aggregation network and above and stuff, that, eventually there'll be lower end products that want to have this kind of functionality for reliability purposes as well. So.
And that is an excellent point, Lauren. The challenge there is that when you get into Atom class products, those guys are very price handicapped.
Price
having
and power.
to drive.
Price and power.
Say it again.
Price and power.
Yes. So having two drives it's already a significant challenge. So what we have done is we are scaling down our Xeon D product family to up to 2 cores. So we are basically trying to preserve the kind of the low power, very competitive type of environment where you may be targeting Atom designs in the past, but bringing additional value and bringing additional capabilities that allow you to kind of have incremental value from a system level perspective. I know that it's a delicate balance, and I know that this does not satisfy in full the direction that you were questioning us, but that is from a product line perspective. We are trying to meet on the high end of Atom to have a very easy transition to the low end of Xeon, if that means something.
That makes a lot of sense. I mean, a lot of the products we look at, it looks like most of the NOSes we work with, they like 4 cores. Sometimes we can get them to use 2 cores. A Xeon offering of 4 cores with hyper threading turned off, right? You don't need hyper threading in those environments.
That is a great point, because one of the things that we have seen with the growing interest from an orchestration and management, as well as from an automation perspective, most of the tooling that already exists for the cloud can be scaled down to a lower number of cores. And you're absolutely right. When you need to run the NOS and you need to run some of the services, you still want to have at least 2 cores or 3 cores to go and to be able to run services in the shape of VMs or containers on those H nodes. And that's why you see the 4 cores as a sweet spot. We also see the same thing on our side ourselves.
Okay.
Back to you.
Very good. Thank you. Very good side discussion. Let's come back to the main thread here then.
Perfect.
Yeah. Well, I have a question. Is there any difference between the E-core and P-core having this capability, or is it like part of the Uncore or something that would allow it to be on any processor, regardless of the core type?
Craig, you are ahead of us. So let me answer that. I think that there's enough public information for me to be able to answer that. So right now, P-cores and E-cores, the way we are planning to bring them to market next year, is going to be, all of them will be under the Xeon umbrella, a branding name.
Okay.
So
Yep.
even when some people make the assumption that E-cores are Atom, in practice, we are bringing additional value to E-cores, and you're going to see that Intel is going to have significant ambitions around targeting telco workloads with E-cores. So it's not an apples to apples when you try to mentally map Atom to E-cores.
Yeah. That no worries. We'll discuss it in the future. Thank you.
Thank you. Shiva Kumar, I apologize for the extra time. Back to you.
No, that is very good actually. So because
we like it.
the new technology, when you really introduce, there'll be a lot of questions on that. So thanks for all the clarification. By the way, if you can see, there is a reference link we are providing. I'm asking the OCP guys whether this link is useful. This will provide more information about the rate technology, etc. If you say yes, it is a part of this, I will add it here. Otherwise, I'll put it in the Word document. Any suggestions?
If it's helpful, Shiva Kumar, we can put it at the bottom of the table, but it's not a short link either. So unless people are getting the electronic version, not the PDF, where they can click on this thing, it's not a trivial thing to type on a browser command line.
You could put a QR code in there instead.
Okay, that may be an option.
Yeah, so just to kind of add here, we do have a short variant of that URL. So if you go intel.com/vrock, it will redirect you to this page. So maybe we can use that particular URL.
That's a good idea.
Good idea.
Exactly. Let's take it offline. Back to you, Shiva Kumar.
Awesome.
Thank you.
Yeah, thank you. Nice presentation, Samantha. Thank you, Philippe. So back to the original box itself. So this box is going to be on NEPS level 3 compliant, and other characteristics of the temperature and the height, 2RU height, and the regular chassis depth, etc. is all written here. It is available in both AC and DC model. It supports, as already told. So it has got timing support also, Sync-E and the 1588 version 2, etc.
So
I have three more slides, but what is the question? Yeah, go ahead. Yeah.
There's a question there. Go ahead.
yeah, for the operating temperature range, I thought central office NEBS 3 was basically 0 to 55.
Yeah. We've been having, hey Lauren, we've been having to accept a lower temperature because of the white boxes, man.
Oh, that question, huh?
Yeah.
So
I'm not sure. We probably should look at that.
Two questions regarding that. So the way we've always interpreted it is NEBS level 3 central office. It was 0 to 50 with 0 to 55 short term, which means you have to design the product to 0 to 55. And then if it's greater than a 1U box, then it needed air filters on the front of.
No, 2RU.
Air filters for
greater than 2RU, right? Then we go to the filters. Yeah, 2RU, you're okay without the filters.
Okay.
It's if you go to 3 or 4. But no, I saw this also, this 45. It's a good point. We'll clarify this.
Just clarify that, and I think we'd all be interested to know whether or not these kind of waivers to NEBS level 3 are really true acceptable and stuff for future design reference and such.
Yep, agreed. We'll take a look. We'll take an action.
Thank you.
Okay, so I'm not going to go deep in the slide. So it is internal details of the block diagram of that router details. As we already discussed, this is Intel details to support 2 SSDs with VDOC functionality, and rest are Broadcom Q2C+, timing module, reverse gearbox, etc. So,
Yeah, this one Ufi should explain.
Doug, Doug, you want to,
Yeah, I'll go through this real quick just so you guys. Can you guys hear me okay? I'm not sure if you can hear me.
Yes, we can hear you.
Okay, good. All right. Yeah, so thanks, Ruba. So this is kind of the use case where this sits in AT&T's network. So I'll start on the right side of this picture. So we have basically core routers, which is AT&T's backbone. We've actually moved to white box DDC architecture. We started that process back in 2018, and Lauren was involved with that, back in the day. We've got quite a few of those up and running now. Then we've been implementing edge routers, similar architecture with the DDC. These are our, in the past there were Juniper and Cisco routers that we put on the edge. Some Nokia routers also. We've collapsed that to white box designs also. So what we're realizing is we want to be able to save some of the ports on these routers, these edge routers. So today we're bringing in 100 gig directly. So that's where the DMUX comes into play. So basically we say, hey, we can aggregate all of our 100 gig access ports and bring them into into the edge routers with this DMUX. So if you just go to the left, basically we have sort of 3 main drivers of 100 gig today in AT&T, OLTs, which are these are sort of your residential broadband devices which aggregate, fibers from customer prems, basically homes, residences, etc. And we want to use 100 gig on those. A couple of vendors have that now. We've got also what we call our D2E MUX, which is this MUX in the center. Those are already 100 gig uplinks. So we figure we can bring them into this new eMux and again avoid using up so many of the 100 gig ports in the edge routers. And they basically do mobile backhaul. That's their main job, although they also pick up enterprise at lower rates, 1 and 10 gig. And then finally, we have now a demand for 100 gig NTEs, both on mobility side and also enterprise. So we could bring the NTE, directly into this MUX. So we sort of have 3 prongs of demand. They're all coming in maybe different timing. We're hearing some of this high bandwidth stuff on the residents isn't coming as quick as we hope, but we believe it'll eventually get there. We see Google and others are starting to compete with offering like 5 gig and higher speeds to home. So AT&T's in that game, so we want this box here to sort of pick up all this load. So that's kind of the premise here. Okay, any questions?
Yeah, one question for this. One of the interesting questions for this large broad network like this is, what are the timing synchronization requirements across the chain? So I think we know we need class C or D out on the edge for the mobile stuff in particular. But back in the core, how far back in the core do you have to implement, really tight syncing and PTP stuff?
Well, so this is a good question also. So I think we got to do some homework, Shiva, on this question.
Right,
okay.
but
I don't want to answer this.
Yeah.
I'm not a sync expert. I mean, I'm pretty sure today we're not doing this, okay? But as this tighter with 5G comes in, we're probably gonna have to deploy some of this, right? So.
Well, it has to stretch. It probably has to stretch to where you have your BNG stuff, at least, I would imagine. But who knows?
Right.
In a strange twist of fate, OCP leads the world in timing and synchronization standardization. Our TAP group actually is kind of working on IEEE's next version of the synchronization standards. So, any chance you guys have to work with a TAP group might pay off.
Well, yeah, I gotta be careful there. Is the TAP group focused on
What is it?
Profiles for data center or for?
No, so what TAP, the way TAP started was they they started working on, you know, data center level, but it's gone to system level now. And so they're working on something called PTC, which they're working with Intel and other, you know, component manufacturers to implement. And IEEE is going to support that.
What is the
PTC.
version number you said? We are supporting 1588 version 2, but is there a new number standard emanating?
Yeah,
from
right.
that?
I forget what its draft number is. It's like 33 or something like that. I don't remember, but I can get that to you.
Yeah.
Okay.
Since we
That'd be
didn't
good.
know, we did not ask for that, but it is a separate micro-SIMI version, etc., implemented by OCP, but then no one is there to represent, talk about it. But if you tell us, you know, in a separate email thread, what is the standard, etc., we may ask them to really support that also. You know, perhaps it is easy for them to really answer and support it. I don't think it's a major problem for them. But we did not, as a requirement, we did not ask for it because we didn't know the new standard, right?
It would not be reflected as a requirement because I believe they're working with Intel already. So I'm sure they could probably pull that forward for you. But yeah, I'll send you guys some information.
Yeah. I mean, and one other comment here is I'm not so sure what support we required for this eMux box necessarily. I think what happened here is UFI has this card and they're putting it in the box, and I'm not sure we asked. I'm not sure if we asked for it, to be honest.
That's fine. Yeah, no problem. This is a pretty standard card for the, you know, it's cost effective. It doesn't cost that much, and it's got some good performance. So if you need timing sync on this platform, this is a good.
Well, yeah, I think that's why we didn't quibble about it.
Yeah.
So
Don't
put
say
it
no.
on if we need it, then it's there.
Yeah.
Right. So, all right. So how we doing here, Shiv, on time? I mean, we got one more chart here.
No, I think one more. No, one more.
All right.
So
we're gonna go quick.
Finish this chart. Yeah.
So the last two.
We'll go quick here. So basically, AT&T has been trying to move towards this IP over DWDM sort of structure. So today, when we have our ROADM systems, we have to buy all these MUX sponders and transponders, all this additional gear that sort of front ends the ROADM system. So we're trying to now eliminate that wherever we can. And what we're driving there is these open ZR Plus and ZR optics. I think there's a ZR4 that's kind of a MSA type of thing, or maybe a proprietary thing. So we just kind of listed all the optics support here. You know, we have a model for third-party optics in addition to white box, where we want to be able to pick and choose different optic vendors, you know, regardless of who it is, you know, pick whatever OEM optic vendor has the part we need. We want to put it on the box. And this is kind of the model that we've, you know, we told UPI we want to keep this model here also on this 400 gig eMux box. You know, sort of the interesting stuff is the Open ZR Plus under the 400 gig column. We've had UFI Space doing some testing there, and you know, we hope that can save us some money because these ROADM systems are very expensive. So wherever we can avoid them, it's good. And probably this is the case for many providers, whether it be a carrier or even data center folks.
Are you doing?
So
one question: is this point to point with DWDM, or?
So no, so we're hoping some of this will be direct fiber. Some of these cases.
Okay.
Some of it we can plug into. I think it's 0 dBm. If I'm getting the terminology right here.
Yep.
But some of it we can plug right into the ROADM system. So there's a couple cases here. This is like a very simplified picture. I think we'll have more detail in the technical doc when we get that finished. But that's the general idea.
Yeah, it doesn't really affect the product per se, right? This is kind of
this is kind of outside this product, but well, it is and isn't, because these are high, you know, they're high powered. So you got like, I forget if it's 22 or how many watts. It's pretty high wattage, right, on these optics. So you have to be able to make sure that the cooling is there to support them.
Yeah. Kind of I coordinate a lot of the optical stuff here at OCP too. And it'd be great to have like a kind of a secondary part of your spec would be to have a interoperability test set or something like that, so that you can, so third parties could you know, whoever wants to make this box, for example, they could run your interoperability test set and verify or certify that it complies to that.
Yeah, and I think, we should all note that in these products, as we're talking about this, typically we're starting to be in a situation where all the ports on the product are not the same, right?
Yeah.
It may be that some part of the products, like the lower row of stuff, supports normal power and the upper row supports high power. And so we have to be very careful to make sure at the product level we actually specify, which set of ports have additional power capability and which don't. That's one kind of
Correct.
bifurcation. Yeah.
Yeah, and in addition, depending on the optic supplier, some of them can. We're finding that some of them can work in all ports and others can't. So you even run into that issue. Which our goal is we don't want to be having to have these complicated engineering rules on any box.
Yeah.
So ideally, we want them to work in every port that it could, sit in, right? We don't want to have to say, port, 0 and 7, we can't put this optic, stuff like that, right?
That's
anyway,
not the trend, though.
I know. All right, Rivakuma, I'm done.
Just to, thank you. That it was great. Just to add to what Doug said, also, we do have like a complete certification testing for each and every optics vendor what we have chosen already, and we really, if there is any limitation from any manufacturing perspective or a particular optics perspective, we do call it in internal our own documents to say what we can do, what we cannot do. If there is any exception, we will call it out. But for the OCP perspective, we do not want to really publish that. It is proprietary because we will be unnecessarily supporting some vendor over the other, etc. Instead, what we are doing is working with those vendors to improve on certain time. But sometimes we also have our rules well established for internal usage. But I don't know whether we can publish all those things to the OCP.
Oh, I totally appreciate your position. I was on the telco side for a good 20 years, but I think the way through that, what I'm suggesting is you could an interoperability spec or interoperability tests could be written at a sufficiently high level where kind of like any standard, right? Where it's not prescriptive. It doesn't tell you exactly all the secret sauce, but it gives you the basics so that if somebody actually wants to make this box for you, they can first run these tests and prove to you that it passed this basic level of tests, and it's got a level of readiness that they can support you.
Sure, but if you have any template separately, I appreciate you can give it, and then we'll work with our ODM and then publish that also. But currently, I don't know, right, Doug, how to really represent them. It will be helpful if you can give us some guidelines on how to do that.
Sure. Hey, Lauren, are you capturing action items or?
No, I was ready to ask a question, but.
Okay. Oh,
Can I intersect with this on this topic? We are marginally impacted by it, and I would agree with the position that any functional testing to the box would be required by any telco to consume the box, but it's a body of work that any ODM that wants to sell to a telco needs to do. So it's a way of lowering the cost of putting together a solution that is functionally correct. And I think that for Intel, making any contribution to make sure that the path of getting that functional testing done, I think that we would be very interested on discussing that further. Back to you guys.
Thank you.
I thought some more questions.
Yeah, this is Lauren. So,
Lauren, go ahead.
Two questions. Yeah, on your very last slide that you haven't shown yet, in terms of supporting vendors and stuff. If you want to increase it a little bit,
This is the one, Lauren?
Yeah,
the one you're talking about? Okay.
Yeah, if you want to increase it a little bit, you could add Edge Core to the supporting vendors, as we were there for some of the conversations with AT&T about this particular product. So if you want to expand the supporting vendors, Edge Core would be happy
so
to.
I will ask you. I'll ask you this question, right? So we worked with both. Doug, you can keep me honest here. We worked last year with both Edge Core and UFI to develop this 400 gig eMux, but that was 2 by Q2C as a Broadcom chip we used, and then we developed that. They developed the product, and then also UFI developed the product, and it was good. However, Q2C plus, what we are using in this box, we did not specifically ask Acton to make the box, but I am not saying that they are not developed. If they have developed it, then we can add them, just supporting vendors in that place. But yeah,
let me double check.
Right?
We did some design work.
Lauren, did you guys build this same one, the Q2C plus box also?
I know we did some design work on the box. I'm not sure how far we took it, so I should probably go check.
Okay. Yeah.
Yeah.
Yeah. I mean, certainly. Look, we back to the openness statement. We want more vendors. We want to be ready if something were to go wrong, right? So I would say we're okay with it. What do you think, Shivakumar? I think so, but
yeah, actually, I'll tell you one more thing, Lauren. I even asked them also, but because they didn't get the order, that's a separate thing. That's beyond the point. But I asked them, if you have a product with this, let me know if you want to participate as a part of the OCP. There was no response from them. So again, I will check, but internally you can also, Lauren, check with them. We don't have any this one. If they are agreeing, we can add it. Otherwise, if they're not willing, I don't want to bring it on my own.
I'll double check and get back to you.
Yeah,
that's good.
The second question is back on the previous page.
Uh-oh. Don't be asking me. I'm supposed to be on vacation here, Lauren.
So specifically, no DAX. Is that what this is saying?
Yeah, no DAC for this. That's
okay.
Right.
Just wanted to make sure
put it this way: we don't care about it, but if somebody wants to build it, that's fine. But we don't see a need for it here.
Okay.
For this use case, anyway. Yeah.
For this use case, okay.
Correct.
Just want to make that clear. Thank you.
Okay. Yep.
That's it for me.
Okay. All right. Thanks.
I do have one more question. So what's the next step? We have already submitted the abstract, and this is the presentation we gave it to the technical committee. This is Telco, right, Lawrence? So what do we do next? What is our pending items?
So I think as far as I understand, this is slated to go before the IC committee tomorrow.
Yeah.
Yeah.
So the point is, if anybody on this call has any comments, suggestions for improvement, et cetera, we should make those to the team so they can make them prior to the presentation to the IC committee. The only one I really heard about was including the overall terabit bandwidth of the solution or the platform someplace in the slide set. And I guess if there's other suggestions for content, you can mail them directly to who's the owner of the document right now? Is it?
I'm the owner. If you can, people can send it to me, then I will compile it and then update it.
Yeah, I have that slight comment. I had a slight change or an addition to the sustainability section.
Something about that sustainability, right? We want.
There you go.
Yeah. So
you got that, Shivakumar? I mean, I got it in my notes. We'll talk tomorrow.
Yeah, we'll talk tomorrow morning, and then we will do that. Sustainability, I took the note. And also the document, we did not really go through that Word document. So we will update that, and it is 95% ready. But I sent it a one copy current version to Rob already. probably you guys have it also. And then offline you can take a look and then let us know if something can be added to that. Definitely, we know Intel needs to update their section. Only today I told them to do it. So we will do that also. And I will take it from there. And already, this is the group today. What Rob sent is the mailing group for all the people who are involved in this project. So if you can, reply all, that is also good. But I'll be the compiler of all the information, and then, updating on the website, etc. when you need it. That's all. I'm done.
All right, sounds good. Any last questions? I think we're done for the day. I will move my presentation to the next meeting, which is fine.
Thanks, Marvin. Good stuff, folks. This was a good presentation. Thank you.
Thank you very much for having us, guys. Thank you. Bye-bye.
Thanks.
Our pleasure. Thank you.
Cheers. Bye.
Bye.